We want to get as many people. So we want all that like the swirls of their ice cream. Plus, we want all of the 8th graders, but we want to subtract those that are common to both. So we want to get as many as we can by uniting them, but we don't want to count anybody twice, which I think we've said before. So swirls, you go to the total. So that would be 533. Plus, we go to all the 8th graders, 250. Okay, here's the swirls, here's the 250. Where they intersect, right here, which I've crossed out. Yes, very good, Humu. 168 minus 168. And if you have your handy dandy calculator, you can add, I'll get that in a minute, 533 plus 250 minus 168 is 615 for the total. And that is over, that's my numerator total, I should say. 615 all over 900 because it's not conditional. And 900 is this bottom right-hand number. Okay? Remember, anytime that says probability, numerator and a denominator. Now, letter C, very important. What's the probability that a person selected is a 6th grader given that she prefers swirl ice cream? So anything past that vertical line, that becomes your new denominator. So let me erase this and find all swirl people. All swirl people. Anybody want to tell me what it is? I know Umu could tell me. I'm sure others could. That is 533 as your denominator. And of those 533, how many are 6th grade? And I've kind of done this a little differently this time. You could go down the 6th grade, but I'm like, all swirl people back here, 6th graders that are swirl people. So that is 212 out of 533. Any questions on that? And the last one, no, it's not the last one for this problem. What's the probability of an 8th grader selected at random prefers strawberry ice cream? Now, I believe, yeah, an 8th grader selected at random, that's a given, that statement. So they have to be an 8th grader. That means I need to find the total of all 8th graders. So that's called a conditional statement. So that means 250 is my denominator. And of that 250, how many prefer strawberry? So I go up the 8th graders, find my strawberry, and that is 82 out of 250. Okay? Letter E, what's the probability that a randomly selected student is a 7th grader that prefers swirl ice cream? That's an and statement. An and statement. So it's not conditional. So that means I know right away my denominator is going to be what? Come on, raise your hand. Show me something. Everybody should be saying 900. Yes, that is my denominator. And then 7th grade and swirl. Here's my swirl. Here's my 7th grade. There's my and, where they intersect. So that is 152. Okay. All right. So, hey, that's the first page. Any questions on that? All right. I don't know if I can get a thing here. Minimize show only active speaker. Show more people. If I can see everybody. Oh, no, that, of course, took it out. All right. Right now, let's see. I would love everybody needs to put something in the chat real quick. Like, I don't know. What could we say? What's your favorite ice cream? What is your favorite ice cream flavor? Mine, anything with peanut butter cups. Favorite ice cream. All right, guys, come on. Put it in there. I need to take attendance. I need to know that you're with me. Oreo. Nice. I think I have a generic Oreo. Mint. My youngest son does not like mint at all. Not like mint at all. You guys were able to see my screen too, right? So Umu is typing something. Please don't tell me you don't like ice cream. I don't know. That might not work for me. Ashley says chocolate. Okay, nice. All right. So let's go back. Stop sharing. How do I get back? Sharing is paused. Oh, no, how did I pause it? Vanilla. You know what? I really like vanilla too. So here we go. And let's go back to this. All right. Okay. And another vanilla. All right, here we go. So number 3, a bag contains 6 cherry, 8 strawberry, and 9 grape flavored candies. How many total candies are in the bag? 14 plus 9 is like 14 plus 10 minus 1. 24 minus 1 is 23. Isn't that funny? People add things together very differently. I don't always do it that way, but for sometimes it's hard for me to do it mentally. Put down the 3, carry the 1. You select one candy, decide you don't like it. I suppose you don't taste it, you just don't like it. Put it back, then select another candy. What's the probability of selecting a grape first and then selecting a cherry? Okay, and we are putting it back. All right, so for my first draw, I know I have 23 total. So if I'm looking for grape candy, how many grapes do I have for that first draw? I'm looking at 9, right? So I get 9. Then I put it back, whatever it is. That chance would be 9 out of 23 that I would get it. Remember, all of this is kind of theoretical. This is what it would be. Times, when I put it back, what's the probability that I would draw a cherry? Well, cherry, I have 6. Since I put that first candy back, that would be 23 in the denominator. 9 times 6 is 54. 23 times 23, I have no idea. Let's check the old calculator. 529. Okay, 529. All right, and the last one for this problem. You select one candy. You eat the candy, and then you select another candy. Calculate the probability of selecting a strawberry each time. Ooh, strawberry each time. All right, so new problem. We still have 23 candies total. Okay. And strawberry, we have 8. So 8 strawberries. We eat the candy. Crunch. Times, we are assuming theoretically that we did get a strawberry on that first draw. Okay? So if I had strawberry, I would now have 1 less candy to choose from, which means I only have a total of 22. And if I did get that strawberry, which I'm assuming I did, that means I only have 7 strawberry candies left. So 7 times 8 is 56. And 23 times 22 is 506. So those are my new probabilities for number 3. Any question about that? I'm watching my time. Okay, we got about 7 minutes. Any of you have any specific problems that you want to look at or do? Anyone? Anyone? Are you all still with me? Give me a thumbs up. Some kind of emoji, something. Ta-da. Nice. Good. Oh, some didn't give me. Okay. All right. No questions, huh? All right. Let's go back to this. Uh-oh. Uh-oh. What'd I do? I just messed the whole thing up. Nope. It's there. All right. Hopefully you still see. Okay. Let's go back to this. I can always make sure I'm doing this. Tuesday. Uh-oh.